Hi guys, welcome back to the next video. In this video, we are going to talk about introduction to containers and Kubernetes. Now, do remember that this is the first step towards understanding your OpenShift because OpenShift is built on top of containers and Kubernetes. So we call it Red Hat OpenShift Container Platform, or its OCP. So this is a full solution for running uh, applications across multiple servers. Like for example, if you want to create a cluster, you can go ahead and do it this way. Now, it is built on two main technologies, which is container and Kubernetes. So you can consider an architecture like this: containers, Kubernetes, and OpenShift. Containers are basically a package of an application which includes its libraries and dependencies so that it can run consistently on any system that supports container. And on top of that, you have Kubernetes, which is used to manage these containers across groups of servers, handling things like scaling, networking, availability. So you can think like this, okay? So for an example, consider containers as servers and Kubernetes as administrators like us. So what we do is like we manage the servers, correct? So as administrator, you need to group these servers as a cluster. You have to handle scaling, like increasing the number of clusters or decreasing the number of clusters as administrator based on the load or demand, and then making sure that the servers are connected towards networking and the servers are highly available across all the time 24 by 7, right? So the same administrative work is done by the Kubernetes, and the containers are basically the servers, like a small containers which runs on a specific server. So that's basically a container. An OpenShift, on the other hand, is like a super administrator. Now, super administrator controls the administrator, and the administrator controls the servers. Same thing like that. So, an OpenShift will use Kubernetes to control the containers. So here, the architecture of containers and Kubernetes will be the same, but there will be another person sitting on top of the administrator, like the super administrator, who will be controlling the administrator, and the administrator will control the service. So think simply like this. However, Kubernetes itself is not a complete platform because it provides functionalities and extensions, but these extensions can be also available on top of OpenShift as well. So OpenShift enhances Kubernetes by adding those missing pieces like security, development tools, automation, management features likewise, turning it into a complete ready to use platform for running applications. So that's the basic introduction. So we have one architecture as well. We will talk about that. So this is a very simple architecture, understanding the container. So this is basically a container overview, you can say it as. So now let's compare a traditional server with the containers. Okay. So how traditional workload can be mitigated into containers. On the left side, you have the traditional workload. So as you can see over here, you have an hardware, which is same for both actually. So you have the hardware as the same. There's no change in the hardware level. But on top of the hardware, on a traditional operating system, you have to install something called a traditional Linux operating system. Now, this could be Red Hat Enterprise Linux, Ubuntu, CentOS, likewise, which obviously will be about the size of 2 GB because it will come with multiple packages. Like, for example, you can build this operating system for a server or desktop, likewise. So it has a lot of packages in it, which makes that particular traditional operating system to be a specific requirement. So, on top of that, when you install this operating system, you are going to have everything installed as a server. For example, you're going to have Samba, you have NFS, you have so many other services will be by default installed, either you use it or not. So some of the servers which you will be installing it for a database server or a WebSphere server, application server, likewise, or you just install it for an NFS server. But the extra features, the extra softwares, which is going to be part of the traditional operating system, will never be used, okay, but still be present. So this is where the problem is, because all these processes, you cannot stop all of them. Some process has to run no matter what. So which means that there is a base utilization of your RAM, which is wasted, right? And then application will run on top of it. So for example, app A and app B. But what app A and app B uses is those limited libraries, as you can see that. The rest of the library which is going to be used will be by the system process or the other process which runs on the system. So that is kind of useless. Now, when you compare this with a containerized application, now on top of an hardware, you have the Red Hat Core OS. Now, Core OS basically has the exact features of whatever needs to be done for that specific requirement. In this situation, we are using a Docker container or OpenShift itself we have installed on it. On top of that, you have the container. Now, containers are designed in a way that it only has those libraries which is required for the application to run, and nothing else will be there as part of the container. So the container operating system size itself would be about 100 to 200 MB of file space. So which means that it's like it has only those libraries required for the application. For example, you can download container which has which is customized for running Apache HTTP server or Nginx server. Now, what this container will have is those libraries which is required to run Nginx server and nothing else. So this reduces the burden on your hardware, where in this situation it only uses zero point 0.4 GB of a memory, which is so much less than the 4 GB of memory which was used uselessly by other processes. Now this reduces stress on your RAM and in turn reduces stress on your CPU as well. Now this container is designed to run app A. So basically it does the same thing, and you have another container which is required to run app B, and basically what it does over here. Now container uses a Linux kernel feature such as namespaces and control groups, which is part of your Linux file systems and Linux architecture. For example, container uses C group for resource management such as CPU time allocation, system memory, so on. Namespaces isolates a container process and resources for other containers that shares the host name. So there is a concept called OCI, which is called as Open Container Initiative. This is a standard where the container image and container runtimes should be maintained. So this is also comes in effect in terms of containers. Now, on the next video, we will talk more about this, and we will understand about the Kubernetes as well. Now, this is what I was talking about in terms of namespace and control groups. Now, let me repeat it again because I think I was on the wrong page. So, in terms of the right side, you have tools over here. So these are the tools which runs these containers. Either you would be using Docker, which is a very famous tool for workloads towards your containers, or if you want to configure a container, you would be using Docker. That's some word you must have heard many a times. Podman, on the other hand, is used as an open source tool. So Docker is not open source, even though it is available for free. There is a lot of limitations of using Docker and Docker Hub. And in terms of Podman is free, but Podman doesn't have a repository. For example, Docker has a repository where you can pull images from Docker repo, but Podman doesn't have it. Podman is just a command which works exactly as Docker. The options which you have or which you give on Docker would exactly work on the Podman as well. Now, using these tools, you will be able to create containers like this. So a little expansion on the previous image. So we are expanding over here. So as I told you over here, there are two options, namespace and control groups. Now, control groups are basically limits the CPU, memory, and input output, and namespace isolate process, network, and file system. So these are the core items which is part of Red Hat Core OS, which is part of any host operating system, which controls the hardware and controls the container as well. So you have the container 1, container 2 image on these containers. which only has those specific libraries which is required for the container. So this is pretty much what I want to explain you on this video, and this is all about introduction to containers. Thank you again for watching this video. I'll see you with more details on the next one.